Dear friends, in this video, I'm going to do a short master class on a very important machine learning algorithm, namely decision tree. What is a decision tree? A decision tree is a supervised machine learning algorithm used for classification problems. The target group is generally a categorical group, binary type. It could also include more than two classes. It's a powerful classification algorithm. So you have a root node, you start a problem with the root node, and then the attribute test. What you mean by that is the root node starts with a particular attribute and then keep dividing the whole thing into multiple type of splits. So it's a recursive partition algorithm that is used, and you have root node, then branches, then finally the leaves and the terminal node, beyond which I will not be able to do any further split. And then I create the final classification. It's very popular for its interpretability and ease of use. So you have root node, then you have branches, then every time you do a binary split or a multiple split, depending on the problem, generally a binary split is easy to do. And then what you do is keep doing it until you are left with a terminal node where it contains the leaves and you count the number of observations correctly predicted, etc., and all that, which we are going to see. So what is the criterion or criteria the decision tree is using? Is very interesting. Gini index. So you start with some impurity and keep on reducing the impurity. To put the other way, you are maximizing the purity possible. And finally, you find out what is the information gain, which is the difference between what you started with and what you ended with. So the reduction in the Gini index is called the gain in information. The same thing applies to the entropy, except the formulas are different. By and large, they lead to a similar type of conclusion, both these approaches. So the Gini index is given by the formula 1 minus sigma pi squared, and I is the particular classification thing. For example, owner, non-owner. And you try to calculate the probability, and then 1 minus sigma pi squared will be the Gini calculated. The entropy is given by minus sign outside sigma pi log to the base 2 pi. The same thing, pi is the probability of the ith class, and you are trying to calculate. And these are the two formulas that are used. And these are used to determine the best split in the tree in each stage. You can have different splits intuitively if you do, but what is the best split depends upon the reduction in the Gini index. So let's see now with an example, a generator example. An electric generator manufacturer would like to find a way of classifying businesses in a city into those likely to purchase a generator and those not likely to buy one. Data contains 12 owners and 12 non-owners of generator in the city. Their electricity consumption and the business income are the features. So let me just show you the data set here. It's a simple problem because I'm explaining how the decision tree algorithm works. That is the goal of this masterclass. So this is the data set containing the two feature variable and the outcome, which is the ownership. Either a person is a owner or a non-owner based on income and consumption of electricity. So this is the problem. Now, what you do is income is a continuous variable, consumption is a continuous variable, but it categorizes the decision tree algorithm in a beautiful way, and it's doing the recursive partition algorithm based splits in every stage. Now, I'll just show you the outcome using the Python program. So you start initially with the root node, which is here. Income is less than or equal to 59.7. The Gini is 0.5. The samples is 24. And if you see this, the value 12, 12 split, class is equal to non-owner. When it is equal 12, 12, you generally start with a non-owner. Because both are equal, I cannot say it's owner, but I have to improve the solution. So class is equal to non-owner. Now, how the Gini is 0.5? Very simple. If you use the formula 1 minus sigma pi squared, in this case, it is 1 minus 12 divided by 24 whole squared minus 12 divided by 24 whole squared, which on simplification will give you 1 minus 0.5, and that is 0.5 here. So you are starting the exercise with the Gini of 0.5 and how much you are gaining in every stage and in the end, in order that you get the best split and the best accuracy. Now, then I'm asking here, income is less than or equal to 59.7 is yes or no. If it is yes or no, if it is yes, for example, then consumption is less than or equal to 19.8. Then I have a sample of 16. The value is 5, 11. So 5 non-owners and 11 owners. Therefore, the classification says class is equal to owner. If you look at the left-hand side rectangle, if it is yes, consumption is less than 21.4, Gini is equal to 0.219. Samples is equal to 8. Value is equal to 711. That means the class is a non-owner. So in this, there are 7 non-owners and 1 owner, and you have a split done, 8 here, 16 here, the totaling of which will give you the 24 here. Now, the exercise is not over. So now this left-hand side, I split this part here when it is less than or equal to 21.4. Sample is equal to this, class is equal to non-owner. I split them. I have 2 classes here, 7 and 1. Gini is 0 here. So I say class is equal to non-owner. Here class is equal to owner. The totaling of which 7 plus 0 is 7. 0 plus 1 is 1. This is the split. It does this. When it is less than or equal to 21.4, they further split and you end up with this part here. Now, that means income is less than or equal to 59.7 and consumption is less than or equal to 21.4. This is the outcome. Suppose income is less than or equal to 59.7 and consumption is not, in other words, is greater than 21.4. This is the outcome. Now let's look at the right-hand side. When I say income is less than or equal to 59.7 is not true, that means it's more. Then I'm asking consumption less than or equal to 19.8. I have got this split here now. So income is less than or equal to 59.7 and consumption is less than or equal to 19.8. That part I have here. When this is negated here, for example, then I ask the question, income is less than or equal to 84.75. Or yes, then Gini is 0.494, sample is equal to 9, value is equal to 5, 4, class is equal to non-owner. Why? The first class is non-owner, the second class is owner. In the maximum voting, 5 leaves are here, and therefore it is non-owner. On the contrary, if this is not S, I say Gini is 0, the samples are 7, value 0, 7, class is equal to owner because 7 is the maximum of 0, 7. This is owner, and this is a terminal node. I can't do further splitting. So in this stage here, yes, no, yes, no, yes, no, it proceeds. And every stage you can do a back calculation. 5 plus 0 is 5. 4 plus 7 is 11. Therefore, the split is correct. We can cross-check and the software uses it logically and correctly. Now, the income is less than or equal to 84.75. Yes, no. Then what happens here is I get a Gini 0.278, samples is equal to 6, value 51, class is equal to non-owner because the number non-owner is larger than 1. This is 5 is larger than 1. Now come to the Gini here. It is equal to 0.0, samples is 3, value 0, 3, 3, class is equal to owner because this is larger than this. And therefore, I have the terminal nodes here, 1 in this color. There is a 2 here. There is a 3 here for the owner terminal node. So if you add all this, 7 plus 3 is 10, plus 1 is 11. So 11 out of the 12, it is correctly predicted because there are 12 owners. Now the non-owner, likewise, this is the non-owner class here, terminal class 7, and this is another terminal class 5, 7 plus 5, all the 12 are correctly predicted. And the logic every stage it is using is the reduction in the Gini index. Now the second class, how the Gini index is calculated, for example, how is it 0.219? How is it 0.43? Very simple. 1 minus sigma pi squared, which is 1 minus 7 upon 8 whole squared minus 1 upon 8 whole squared. If you simplify, this is equal to 0.219. Likewise here, it is 1 minus 5 upon 16 whole squared minus 11 upon 16 whole squared. And if you simplify, you will get 0.43. And that's how this is done. Now you may ask me, there is one Gini here, there is another Gini here. How do I measure the information gain? There's left-hand side and the right-hand side. Now, very simple. Apply a weighted average of 0.219 and 0.43. How do I know the weights? Very simple. The samples here are 8 and 16. So 8 divided by 24, multiply 0.219 by 8 divided by 24, multiply 0.43 by 16 divided by 24, add these two, the weighted average will be around 0.36. And therefore, the gain at this stage is 0.5 minus 0.36, which is 0.14. You can easily do all these things. So this is the beauty of the algorithm using the Gini index. Now let us look at the confusion matrix, which is the matrix of classification. And I'll just show the confusion matrix first. I just want to, sorry, I also want to say by a similar logic, just like the Gini, I use the entropy formula as the basis, and the entropy is minus sigma pi log pi to the base 2. And when I do that, this is the tree, but I get a slightly different confusion matrix. And you can see how many are correctly predicted. This is the terminal node for the owner. This is another terminal node. The rest of them are not terminal nodes. So 5 plus 5 is 10. 10 out of 12, it is correctly predicted. The non-owners is pretty simple here. This is 1 here, 2, 3, 4. I add 0 plus 7. Sorry, this is not the terminal node. This is the one 7 plus 3. This is terminal node. This is also. So add this 7 plus 3 plus 2 is equal to 12. It has correctly predicted all the non-owners. Now, the relative importance is calculated of the two feature variables by what's called the reduction in the Gini index. And for each variable, which is more important, is beautifully graphed by Python. And as you can see here, this is the scale here, and 0.6 is here. This is 0.4. So income is 60% important. Consumption is 40% important. So on a scale of 100, income is 60, consumption is 40. So constant sum scale, out of 100, 60 points for income, 40 points for consumption. Then I do what's called the confusion matrix, prediction versus the actual, non-owner, owner, non-owner, owner. The first one is the Gini. The second one is the entropy-based method. I calculate, and I see here 23 out of 24 is correctly predicted. And here 22 out of 24 is correctly predicted. And therefore, the accuracy in this case is 23 upon 24, which is pretty good. And if you use a simple calculator, I haven't done that because I'm interacting with you. So 23 divided by 24, the overall accuracy in the first case of the Gini is about 96%. And in the second case, it is 22 divided by 24, it's about 92%. So it's 96 versus 92, which is overall accuracy. Then what is recall, precision, F1 score? Precision, recall, F1 score, I start first with the recall. The recall measures prediction of owner given actual number of owners. Now, the actual number of owners is 12, 1 plus 11, as you can add, out of which the model has correctly predicted 11 owners correctly. So 11 divided by 12 is the recall, which is 0.9166 or a 92% recall. What is precision? The precision is actual given prediction. So the number of owners predicted here is 11 plus 0 is 11. Actual owner is 11. So 11 divided by 11. In this particular case, it's a simple problem to illustrate. Every case, it will not happen. It's 11 divided by 11. So precision is 1. So precision, recall. Now, what is the F1 score? The F1 score is important whether there is a balancing effect, and it is calculated as the harmonic mean between precision and recall. So precision is 1, recall is 0.91667. If you use the formula of the harmonic mean, which is 2AB by A plus B, you are going to get 0.9566, or 96% is the harmonic mean here, which is the F1 score. which is pretty good. Now come to, this is the Gini index-based confusion matrix. The second one is the entropy-based tree confusion matrix. And if you look at it, this is 12, as I told you, it's about 92% accuracy. The recall is 0.833. It has come down. How the recall is calculated? Actual prediction of owners given actual. So actual owners are 12, out of which 10 is correctly predicted. 10 upon 12, that is your recall. Now, precision. Actual given prediction. So the prediction is 10. Total 10 plus 0 is 10 is the predicted owners. Actual owner is also 10. So precision is 1. Now, if you calculate F1 score, the harmonic mean between precision and recall, it is 0.9090. It's about 91% versus 96 here. Gini has done better in this case. Of course, every case it may not. More or less, they will, both these approaches will give similar results. Now, look at the last one, which is the ROC curve, which is very, very important. Now, the Gini calculation, the Gini color is here. The dotted ones color entropy, the random classifier, which is the divider. And you always expect the ROC curve, which is plotted the positive, true positive versus the false positive, right? And when you do that, this is what it is, a beautiful one. 98% area covered in Gini, 97% area covered in entropy. It's a small gap here, pretty good result. And the magnificent technique, I hope you are able to appreciate this. It's just a starting. And with this, you can build the logic for all kinds of problems, the training set, the test set, and a case study. Everything is possible if your foundation is strong. So this is the masterclass. I thought I leave it here. And thank you very much. We will see you soon.